Greetings from my hotel room. So I'm currently thinking of whether I should make a video on the recent seminar that I attended. But the thing is, I'm not really a kind of a guy who really does this kind of videos. So as I was working on my laptop and was charging a couple of my devices, as I got to leave for tomorrow back to home, which is quite sad to be honest. But yeah, I had an awesome time right here where I'm staying, and the fact that I got to attend such a nice seminar on gravitational waves is really a game changer for me right now, because I got to connect with people who are real pioneers in this field. Whatever. These are my reflections on the seminar. First of all, the brief idea about seminars is that you get to meet a lot many number of people. Some of them are the leaders in their own sections, in their own fields, and you get to talk to them and explain your ideas about the topics that you have pondered for a long time. But this one was quite extraordinary, to be honest, because I got to meet some real geniuses on this show, and they are quite frankly the real pioneers in this field. So a little about gravitational waves. Gravitational waves are a brief way of saying that the space-time fabric in the Einstein's general relativity predicts, or I say that bit wrong, to be honest. It doesn't predict. The space-time fabric is an idea. It's an unpleasant way to call it a fabric because it's not a 2D plane. It's more of a 3D plane, so it's like a sponge. So it can squeeze, it can expand, or it can get rippled, as to say, as we have observed it in gravitational waves. So gravitational waves are something quite like waves, but they are not quite like the other waves that we have seen, like the electromagnetic wave, which is a thing that can pass alongside the space-time 3D manifold. That's the word actually, the manifold. So it can actually go around the space, as you can see, and it gets affected the way the space-time is bent. For example, in general relativity, if you observe the Eddington's experiments back then, he did a couple of fascinating experiments, and those were completely based on the fact that we needed to focus on the ideas that whether the space-time manifold, or the fabric for now, okay, just take that as a fact, that the space-time fabric gets bent due to mass of the star or any planetary body. But however, the thing is, we are not really taught this in any high school courses, which is far beyond the reach of most of the people for now. So I will make this a bit short and simple. So the thing is, whenever there is a space-time, let's say this table, it's rigid right now, but imagine something like a trampoline. When you get a trampoline, whenever you jump on it or you keep a heavy object right on the top of it, what happens is that the fabric kind of bends around the heavy object. Imagine if you keep a very heavy metal ball on it, you will observe that the trampoline gets bent along that mass. That is actually something you're causing a bend in the space-time fabric. And after that, if you bring another smaller mass as compared to the bigger, heavier mass, you get to observe something called the planetary motion if you do some things to that systems. And what do I mean by that? It's if you have that heavy mass just in that trampoline, and after that you bring a smaller mass and give it some kind of a velocity around that heavier mass, it will actually start rotating around that heavier mass like this. So it's actually a way of representing the motion of the planets around its star. However, you will see that those kind of systems actually are unstable, because there is the energy of that system that is getting taken away by the friction on the trampoline. So the planet will eventually fall onto that star. It's not a quite equal approximation to the what's happening in real time, because there is no friction whatsoever, or it's really small out there in the vacant space or the vacuum. So yeah, if you can imagine the situation to be in the first few seconds, whatever happens in the first few seconds of that experiment, the first very few seconds of the experiment is quite like this situation what happens out there in space, whatever. But as I mentioned, that space-time is not a fabric, it's not a 2D plane, it's a 3D place. So yeah, imagine it like a sponge, and that sponge is bending around objects heavier inside of it. So it's quite hard to imagine, but yeah, it's like a 3D plane. So there are layers of it, and you will observe, if you, I will try to put up a picture somewhere here or there, or maybe I'm bad at editing, so I'm not quite sure about that, but whatever. And after that, the heavy object will actually bend the space-time fabric. Actually, there's a nice quote from John Wheeler. I cannot really quote and unquote him because I don't really remember the quote right now, but he said that matter tells how the space-time to bend, and the space-time fabric tells how the matter to move across the fabric. So that's about it. You get a general, very layman and rough idea about how space-time fabrics work and how the manifold works in general relativity. But whatsoever, I actually had a question about gravitational waves. What are gravitational waves? Back to that question. Gravitational waves are something like, imagine ripples in that space-time fabric. It's like when you have two balls near about the same size, and what are these two balls? This can be a neutron star pair, or a neutron star black hole pair, or a black hole and a black hole pair. Of course, the last one will be the strongest one, because the masses of the black hole are quite heavier in general, to be honest, in general, than the neutron stars. The range of the masses for the neutron stars observed until now are like 1 to 2 times the mass of the sun, but there are subsolar neutron stars which we are trying to find out. Yeah, for black holes they are mostly like 66 times, 67 times, or maybe 80 times. It's a larger number than that, but there are speculations about black holes being in the subsolar mass range of masses, because there was this researcher from Penn State who talked about how subsolar masses of black holes can also be a crucial factor in determining gravitational waves. Gravitational waves, I'm skipping away from the topic, that's a weird one to be honest, but whatsoever. If you observe two objects that are really heavy and are actually going round one another, they are actually emitting the gravitational waves. And how are they doing so? So there's this nice demo from the Royal Institution's YouTube channel, and they have this, like, when you put two, whatever that they did was a perfect demo. But for general people, generally we can talk about, let's say there are two heavier balls which can rotate about an axis. Like, we have this one axis and there is another one fixated out here. It's fixed out here. There's one axis and there's one axis here. They are both joined together, and there are two balls, one on here and one on here. So what happens after that, you start rotating them really fast with the help of, as they did with a drill machine, but whatever, it doesn't really matter. And if you put that on top of a fabric, of the space-time fabric, as a 2D fabric for now, you will observe the gravitational waves, or the apparent example of how they can work. It's a rough idea about this. I will put down the link of that video right down here. Not really sure if it's open source, but yeah. Also the fact that I'm quite sad because this is the last day right now. I got to attend this seminar for 2 days. I got to meet people there, and yeah, there were long papers. In fact, I asked a question to some of the I asked questions to most of the people, and yeah, the fact that you can actually ask the leaders at LIGO and gravitational waves, it's just beyond me, to be honest. Okay, whatever I said until now was out of pure adrenaline rush. However, I will try to stick to more briefer context for now. I can quickly show. I decided to make this video, to be honest, right inside my hotel room because it has a nice TV right here. It has a nice smart TV right here, and we can actually see what I talked about, but that's a later part. We can share that video later on. To be honest, here I am right next to the chairman and the head of the department, the vice principal of the university. This is me, but yeah, whatever. I was asking a question to Mrs. Sarah, and yeah, the question was all about, I was just rewatching this video all once again because I wanted to get the most out of it. And yeah, I'm planning to leave tomorrow this place, and this has been quite an adventure. Most of the gravitational wave papers are right here, so you can actually watch the video and get an insight into what these things are. But yeah, the session was actually really nice, but it was long. It was an 8-hour long, or maybe 9 hours, I don't really know, I forgot. Yeah, whatever it was, let's say 9 hours. So there were like 3 hours, 3 hours, and another 3 hours, so breaks, 2 breaks in both of them. But yeah, you cannot really understand or feel any kind of, you don't really feel tired when you attend this kind of seminars, right? At least for me, actually. Whatever. Nextly, the sessions were quite nice. It started with quantum mechanics, insight into quantum mechanics, and after that it shifted to gravitational waves. The session started with quantum mechanics, and it moved into gravitational waves and general relativity. But general relativity is really important to understand gravitational waves, because gravitational waves are just, I don't really know if I should comment on this right like this, because gravitational waves are just a subtopic to general relativity. They were meant to be found out, but we just didn't really have that instrumentations. It's just like that we know about gravitational lensing, or we used to know about them back then, but just after Eddington with his experiments proved it, we got to know, yeah, it does really exist. But we predicted about gravitational lensing back then. And yeah, I'm planning to write a few reviews or on my notebook about what I got to learn from here, and then maybe publish a brief intro to gravitational waves to whoever is going new in this field. To be honest, I am technically new here too. And yeah, the trip in here at this place was really nice. I am in the western side of India. It's a country in the Southeast Asia. I hope you know about this country. And yeah, I got a few nice pencils and pens right here. Bought them off here today. And pretty much that's all. I don't really know if my YouTube uploading schedule is going to be irregular, or it's going to get uploaded every pi number of days, but whatsoever, I will try to be as regular as possible because I want to attend more seminars and more places. I just want to meet new people. I just want to work with physics, and that's all. Plus the fact that the last week has been very hectic but very rewarding too. I got to upload a few data sets from the asteroid finding committee in NASA, and yeah, that's all. I worked there as an intern for, or you can say as a volunteer for now, and yeah, that's all, to be honest. these are some of the pictures I took. My laptop is getting really slow right now. I'm not quite sure about whether I should show this to you right now, because this can take about 3 to 5 minutes to load actually. So if it happens, let's chat about what happened after the... Oh, this is here already. This is a thing called the Pleiades, or I'm not quite sure about how it's pronounced, but yeah, this is a picture I took with the remote telescopes in the Institute of Astrophysics in the Canary Islands. Uh, Pretty much, to be honest, this is one of my best pictures that I've ever taken. And yeah, these are all stars right here. It's also called the Seven Sisters, and this is quite famous, to be honest. On a clear night sky, if you go out there and look just next to the Taurus constellations, it's mostly near the Taurus constellation at times, but yeah, it can shift away depending upon the time of the year. Not quite sure about where it's now. I need to look it up. I will just put it in the comments. Okay, this is one of the places which is called the Seven Sisters. This is the Pleiades constellation. This is the Pleiades. This system is very, to be honest, it's very beautiful, and these are all stars that are getting formed. I'm not quite sure if you are able to see this in the best quality because of me streaming it from my phone's camera and then to the screen, so that's a bad one, to be honest, but whatever. That's where probably I will try to end my vlog, or whatever this is. It's not really a vlog, it's an educational insight into the life of a struggling student, but whatever. Yeah, this is life, and I intend to work with things in physics. Let's see how this thing goes. Thank you so much everyone for hearing this. Thank you so much. Bye.